Right, so up until now we've created the to-do app, we've created a create, find, read, update and delete action for our to-dos. And the next thing we're going to do is integrate it with sconfig and loglet. So I have here this sconfig page. I'm just going to log in with unlock and create an application. My to-do app. It's a development one. I'm going to click here, use sconfig discovery so that we can actually use the discovery system that's built in. And I'm going to go back here to versions. So you can see, create a new version, v1, and it's a JSON JavaScript configuration, no access logs, and I'm just going to use this as store.sql. This is essentially where you're going to store your actual configuration data. And we're going to go back to our example, and in our development environment, I'm just going to copy this and place it here so that this is where you're going to store all your credentials and so on. And then we're going to integrate with loglet, which essentially is we're going to use plugin.loglet, and it will have a key and a secret. Save here and go to loglet.io. Just sign in with unlock. Again, I'm going to sign in, send my encryption key, and here I'm also going to create an application to do that. Development one. And I'm going to go here and select create a new access key so that my actual Node.js application is going to have access to the application. Just one. So I have my key here, and if you view it, you see here a key and a secret. I'm just going to copy this key and place it in my configuration file here. Copy the secret and place it here. Just save it, and I'm going to go here at the live stream, so we're going to see logs incoming in. Coming back to our project, we are going to. So we're going to use. I said we're going to use the loglet here, the loglet plugin. So I'm just going to add plugin. Acquire Thorin plugin loglet, and I'm going to install it. Okay, Thorin plugin loglet. While it's installing, I'm going to go back to my app and say, alright, so I need Thorin to add a configuration source. The source type is sconfig, and what Thorin will do is it will look for a environment variable called sconfig key. So by default, in practice, you're going to have that sconfig key inside your environment variable, but for this example, we're just going to place it here, process.env.sconfig key equals, and we're going to go to the sconfig application here, to the details page. We see here that we have an API key, and then we're just going to use this full configuration access key from here, and go back to our application here, place it here, and essentially just this should suffice. And when we start our Node to-do app, essentially what's happening is an API request is made by Thorin to sconfig.io to fetch the actual configuration data and merge it with local configuration. So if you see here, if I remove this from my local development configuration and restart the program, it's still going to work because it just fetched the configuration data from sconfig, and essentially back in our code and in the repository that we're going to use, we have virtually no kind of access tokens stored, no type of credentials. The only thing that we're going to have is this sconfig key, this long version of it, and this one is going to stay inside the application environment variables. So if you're deploying on CentOS and you're using Process Manager 2, PM2, you can just, in your configuration file of PM2, you can just specify environment variables and just add this sconfig key, and it should essentially work. If you're planning, and I highly not recommend it, if you're planning to use that key and check it out in your Git or servers, I suggest you go to the firewall place and just add an entry with the IP of your servers, so that in the event that your sconfig key is compromised, people don't actually have access to the actual configuration data. So this is the least you can do. Now, going back to our project, our example, we are running Thorin plugin loglet, and if we go here, we already have the stream of logs that are coming from our application in real time. You can actually search them here with a start date, end date, and you can filter based on different types of filters. If you want to see the actual live stream, I can go like this and restart it. And you're going to see the logs coming in real time. If I'm going to do some kind of requests here, you're going to see that everything's in real time and everything's streamed down to the browser. Now, this is also the loglet is the actual case study that I presented earlier. So it's working on Thorin. It has all the architectural decisions that we're planning on maintaining. So for now, I'm just going to remove this plugin so that I just disable loglet for now. And if I'm just going to restart the server, you're going to see here that the stream stopped. So yes, it took me 3 minutes, maybe 2, to set up a centralized configuration for my application and to add centralized logging and real-time streaming of them in the browser. So technically, my application should be production ready if I want to deploy it right now. I have, even if I deploy it on 10 servers, all those 10 servers will stream all the logs inside my browser, so I can check if anything goes wrong. So yes, coming back to the sconfig app, when I create an application, my to-do app, there's a small, input here called use sconfig discovery. So as I was talking earlier about the built-in Thorin discovery system, it's called discovery.sconfig.io, and it's used by Thorin modules to essentially register themselves inside a cluster. So next we're going to use npm I Thorin plugin discovery. Next we're going to use this plugin to create a small little cluster that will be maintained and essentially discover separate microservices. Now the first thing we're going to do here, and for this to work, is just add the Thorin plugin discovery, and that's essentially it. You're going to see here that our application just joined the registry cluster as a receiver, and it has 2 nodes. And it also fetched discovery token from sconfig. So this is built in Thorin. Now we are a node part of a cluster, but we are the only node. So, what can this discovery process do? Well, in essence, it can proxy requests from one service to the other without you ever thinking about, okay, how do I authorize these requests and how do I manage the discovery system and the IP of separate microservices and so on and so forth. So I have here a small, I'm going to create a new small project called to-do mailer, where essentially I'm just going to copy all this here for the sake of saving some time. I'm just going to use the discovery one, the transport one, Thorin. Actually, I have a small template that I can actually use in terms of the package. I'm just going to use this one, to do mailer. And I have the mail plugin works with Node Mailer's Mailgun transport. So out of the box, we're working with Mailgun. You can add your own mailer transport layer, but this can be up to you. Yeah, so we're using Nunjux again with as the rendering engine. We use the plugin mail to send out mails. The render one to render those mails before we send the actual HTML, and that is pretty much it. Now I'm going to copy and paste this mailer.js here, remove the old to-do.js, and have this, while we do this, just to-do mailer, npm install my modules. Coming here, this is a normal mailer application, and I'm just going to add the sconfig configuration fetcher even if we're in development mode, and get this sconfig key from here and place it here. Again, you shouldn't do this in a production environment, but for the sake of timing, I'm going to remove the models and the views from the mailer and middleware. I'm just going to leave one single action, and that action is going to be called mail. The other ones we have in config, we don't even need this configuration, we don't need this one, we just need the CDN one, 3001. Now, because this is a separate microservice, we still need a transport layer for both services to communicate with each other. So we're going to use transport.port, I think, transport.http.port. We're going to put it to 3001, change the port, HTTP port. Remove this from the development mode, and with the production mode also remove this. Essentially, we have our small, this is going to be called mailer. By default, the name of a Thorin application is the actual file name that you use to start to boot up the application. So in this case, it's mailer.js. So we're going to have, let's see what we're going to have. Thorin app, Thorin.app. Actually, Thorin.id. Let's see if it's okay. It's installed. Node mailer.js, and let's see what's happening here. Could fall back to previous persisted. Okay, configuration not found. Yes, because we wanted to fetch a version that does not exist. So just remove this part here and just restart. All right. So the first thing that we see is a fatal error that the mail plugin says, okay, I'm working, but I have no valid transport, so I cannot actually send out any kind of mail because I don't know how. So that means that we're going to go back to the configuration here inside mailer, and we're going to say this: my plugin.mail. I want you to use. I'm just going to copy some configuration here. I want you to be in a disabled for now and use this administrator email and use these options to work with mail.app. So this is going to be blank for now, and if we restart, we're still not receiving any kind of transports, and this is because yes, because in the configuration file here we have to specify the transport that we're using. Transport mail.app. So how this plugin works is when it boots up, it tries to require this transport in this format. So we have node mailer, as I said, this plugin works with node mailer. We have node mailer, transport name, and then we have transport. So that all these transports have the same interface that is used by node mailer. Alright, so now we have here join the registry cluster as the receiver. This is the mailer app, and I'm just going to open up a second command prompt, and where are we here? Let's see. Go to the app. Node to-do.js, and it's going to boot up and said, okay, I joined the registry cluster as a receiver, and automatically it knows about the mailer app. So, because we have here nodes too. So at this point, we have a small cluster of 2 microservices that can communicate with each other. Now, how are they going to communicate? Alright, in our action, this is an action that I just copied from a different project. It says, sends an email using the given template and arguments from one of the internal nodes. That means that this is the usual, we have this Thorin dispatcher. This is a reference to the mail plugin. And this being a microservice, it does only one thing and it does it good. So the action that it exposes is called mail.send. And then we have here authorization discovery hashtag proxy. Now, the discovery plugin just added an authorization middleware that's called discovery hashtag proxy, and it handles all the communication authorization between different nodes. So if you're going to look inside here as config, you see a discovery key. This key is used by the discovery plugin to register inside this key actually represents a discovery cluster. So what these two processes do is they go to the discovery system and they say, okay, this is me, this is my token, I want to join this cluster. And then the discovery system says, okay, you can join this cluster, but who are you? Okay, I'm a mailer app, this is the IP that you can contact me, this is the port that you can use to contact me, and essentially every single node of the cluster does this, and at the end of this we have a cluster representation. So we have 2 separate nodes. The one is a mailer application, the other one is a to-do application within a cluster that share the same authorization key. Now, so that when the to-do app wants to send a request to the mailer app, it just sends out this authorization key inside the authorization header of the HTTP request, and this node knows how to actually check whether or not that token is valid and coming from the same cluster that this node is in. So if you remember back here when we were talking about where is it? When we were talking about this, all those 4 or 5 applications are in the same cluster, sharing a single key, and the authorization header is based on that key, so that a request coming from the web API that is sent through to the API instance is going to be valid because they both share a key that can validate each other. All right? Good. So in this case, when we are using this authorization, we know that this action is coming from someone within the cluster, but that someone is authorized. Okay? So then we just say, okay, this particular microservice action needs a to, a subject, a template to use, and parameters that will be used when we render the actual email template. So essentially, at this point, this is the data that we're using, and the mail plugin exposes a send function which has to, subject, and template. And then the second argument is the actual parameters that will be sent out to the Swig template in this case. At which once the email is sent, just do a log and then just finalize the request. If anything happens, just do a log and then finalize the request. So this is our small app, mailer app, that handles essentially email sendings. Now the only thing it requires more is the actual templates that we're going to use. So we're going to go ahead and create a directory here called emails, where we're going to store all our HTML emails. So I'm just going to go on and fetch a layout, a previous created layout.swig. Just use this, the one that we used before, and let's go with just use this feedback. So in this case, you can have your, let's say that you're a company or startup and you want to send out emails to your clients, right? But you have a layout and you want to stick with that layout. So you have a header, some kind of content, and a footer, right? The way you can do it is you can actually create a layout template file. You can create a block called content, and then whenever you want to send out an email, that email's template in this case is going to be called feedback.swig, which extends the actual layout, and wherever the content block is, just add this HTML. And finally, once the email plugin is going to render the entire HTML, it's simply just going to pass it through to Mailgun in this case, and Mailgun is going to send it out, and we have essentially a small emailing app that is able to send out emails. Okay, so we can actually try this out. We're going to restart our to-do app and restart our mailer app. Now bear in mind that for this example I have disabled the actual sendings, enabled false, so that I currently don't have a development Mailgun key, but you will be able to see in the console something that we're sending out an email. So let's go back to our to-do application and say whenever a account is going to register, here at the beginning we have our OTH plugin, and just add our discovery, Thorin plugin discovery. Alright. Okay, so this is where we actually save the account, and we want to send out an email to the user, right? So just add another call. Return this discovery object dispatch mailer mail.send, and then we have the actual payload. Now the mailer app so the mailer app works with the input to, which is account objects email, subject, welcome board, and template, we're going to use the welcome template .swig, and finally params, we're going to send out first name, account object. Actually, we're just going to send out the actual account. So we have account object to JSON. right? And then, just to make sure, send out email. Now, what this does is essentially the to-do app telling the discovery app, to the discovery plugin, to dispatch an action, which is called mail.send, to the mail microservice called mailer. Now, our cluster might have 2, 3, or 4, or 10 different mailer applications that are running. But it really, frankly, doesn't matter to which one we're going to send, right? So if we have 2 mailer applications, the discovery plugin will try to send to the first one. And if the first one is unavailable, or it cannot connect to it, or has a request timeout, it's going to send to the next one. And if the next one passes, then it will just resolve the promise. If the next one fails also, it will try to do this until at least one available node is reached. If none of them are reached, it will just reject the promise. Now in this case, this is simply just an email sending, so we don't actually want to crush all the requests just because we couldn't send an email. So we're just going to go like patch log warn could not send email, register email. When you catch a promise within a calls, that promise is not rejected anymore. It's essentially resolved. So what I've done here is, okay, if this promise fails, everything stops. If this promise fails, everything stops. But if this promise fails, I'm handling the fact that it failed, and the request will still continue as nothing happened. This is promise chaining 1-1. So if you have 10 promises, the one that you catch, the one promise that you want to catch the rejection here, if you do not return E or return promise reject E, this essentially will say, okay, I caught the error, I did something with it, but I still want to fail the request because this is a fatal error. I don't know. But in our case, we're just going to handle the error and simply just gracefully finalize the request. The account was created, but worst case scenario, the user didn't get an actual email. Yippee. Less spam in this world, I guess. Alright, so at this point, let's test out what we actually wrote. Now, the thing that I have to change here in the emails, we're using this template called welcome.swig, and just change from feedback to welcome.swig, and just use this layout as it is, and welcome here, hello, welcome, and then just account JSON, actually just dump it so that we can see it. That's pretty much it. Now remember, the mailer app is actually in email sending is disabled, so it's not going to send out an actual email, but whether it's just going to print it out.